Hello, this is the luckiest maths teacher in the world. Thank you so much for tuning into this video in which we're going to review operations with fractions. So we're going to start with multiplying and dividing because they're usually easier with fractions. So if you have two fractions multiplied together like this, it's really simple. You just multiply the numerator, the two numbers on top, and then you multiply the denominator. So this will be 1 times 3, 2 times 5, easy as. Sometimes it will help you to cancel. So let's say I had this fraction times this one. It would take me a long time without a calculator to do 77 times 80 and 120 times 33. So what I can do to make this easier is I can cancel any number on the top with any number in the bottom, as long as there's a times between them. And I can do that by dividing by common factors. So 77 and 33 have a common factor of 11. So 11 goes into 77 7 times, and it goes into 33 3 times. 80 and 120 have a common factor of 20. 20 goes into 80 4 times, 20 goes into 120 6 times. So then I get 7 times 4 is 28, and 6 times 3 is 18. So this is so much easier doing it this way. 7 times 4, much easier than doing 77 times 80. Now, when you get an answer like this, sometimes you need to simplify. So remember, simplify, you divide top and bottom by the highest common factor. So 2 goes into 28 14 times, and it goes into 18 9 times. That's an improper fraction because the top number is more than the bottom number. If I was asked to write it as a mixed number, 14 divided by 9, 9 goes into 14 once, remainder 5. So it's 1 and 5 over 9. Either of these is the answer. So when you're doing multiplication, remember that of means times. So if I have something like 3/5 of 35, that means 3/5 times 35. When you're timesing by a whole number, people always make this mistake. They times top and bottom by the whole number. No, this is what you do. Timesing by a whole number, just write it over 1. 35 and 35 over 1 are the same thing. So once again here I could cancel. 5 goes into itself once, goes into 35 7 times. So this is just 3 times 7, which is 21. Now, if you have mixed numbers, first convert them to improper fractions. So let's say I have 1 and 3/5 times 2 and 1/10. Each of these is a mixed number because it has whole number part and a fraction part. So remember to convert to improper fractions. The numerator, I go 1 times 5 plus 3 is 8, and I keep the same denominator. Here, I want to convert to an improper fraction. 2 times 10 is 20, plus 1 is 21, and I keep the same denominator. So, to make this a little easier, 8 and 10 have a common factor of 2. So I can go 4 times 21 is 84. 5 times 5 is 25. So to make this a mixed number, 25 goes into 84 3 times, remainder 9. And then we're done. All right, let's now have a look at division, which is very similar. So when you're dividing fractions, you keep the first fraction the same as it is. You flip the second fraction and make it a times. So this here, 2 times 8 is 16, 5 times 3 is 15, and if I wanted to write it as a mixed number, it would be 1 and 1 over 15. So let's say it's something like 6 divided by a half. Heaps of people get this wrong and say it's 3. It's not. You need to follow the same process. So I keep the first number the same. I flip the second fraction and make it a times. Remember, when we're multiplying, you just write whole numbers over 1. So I go 6 times 2 is 12. 1 times 1 is 1. I don't need to write the 1 on the bottom. The answer is just 12. So let's say I have 4 and 2/5 divide 3 and 3/10. As I explained on the previous slide, if I'm doing the operation involving mixed numbers, I first convert them to improper fractions. So 4 and 2/5, I go 4 times 5 plus 2 is 22, keep the same denominator. 3 times 10 is 30, plus 3 is 33, and I keep the same denominator. So I haven't actually done anything or flipped anything yet, so it's still divide. So now I'm going to do exactly what I did in the previous questions. 22 over 5, I'm going to flip the second fraction and make it a times. Just as I explained on the other slide, sometimes it's a lot easier to cancel here. You can cancel anything on the top with anything on the bottom. Rather than doing 5 times 33, I'm going to make it easier on myself. 5 goes into itself once, and it goes into 10 twice. 11 goes into 22 twice, and it goes into 33 3 times. So now this just becomes 2 times 2, which is 4, over 1 times 3, which is 3. 4 over 3, or 1 1/3. All right, now we're going to look at addition and subtraction, which is slightly harder. So when you're adding and subtracting fractions, you need to remember we only add or subtract the numerator. So for 2/5 plus 1/5, the answer isn't 3/10, it's 3/5. We just add the top and we leave the denominator as it is. Second one here is exactly the same, except instead of going 2 plus 1, I go 2 minus 1, which is 1, and I leave the same denominator. What makes addition and subtraction harder than multiplication and division is that the fractions must have the same denominator before you add them. If they don't, you must first make them have the same denominator. So let's say I wanted to add 1/5 and 3/8. I can't add them as they are because the denominator, the bottom number, is different. So I need to use equivalent fractions, which we learned in previous lesson. So what I'm going to do is I'm going to times top and bottom here by 8 and top and bottom here by 5. So why am I doing that? If I times 5 by 8, this denominator will be 40. 40 is divisible by both 5 and 8. That's why I want both denominators to equal 40. So if I times this bottom by 8, the denominator becomes 40. But if I times the bottom by 8, I must times the top by 8. Similarly here, I times 8 by 5 to get to 40. If I times the bottom by 5, I must times the top by 5. So 1 over 5 timesing top and bottom by 8 gives me 8 over 40. 3 times 5 is 15. 8 times 5 is 40. Now these two fractions have the same denominator. They can be added together. You only add the tops, you do not add the bottoms. So let's now do an example involving mixed numbers. So once again, you might like to make each of these mixed numbers into an improper fraction. So 3 and 2/5. I go 3 times 5 is 15, plus 2 is 17. So that's 17 over 5. 2 and 11/12. 2 times 4, 12, is 24, plus 11 gives me 35. So I get 17 over 5 minus 35 over 12. So this is a tough one, but it is possible. I'm going to times top and bottom now by 12. Top and bottom by 5. That will make both denominators equal to 60. And if both denominators are the same, then I can add the fractions. So 17 times 12 gives us 204. 5 times 12 is 60. 35 times 5 is 175. 12 times 5 is 60. So now this is easy. I have the same denominators, so I just go 204 minus 175 is 29, and I keep the same denominator. All right, let's look at a couple of worded problems. So let's look at this one. In a class of students, 5/6 of them had blue eyes, 1/10 had brown eyes. What fraction has green eyes? So view the class as one whole. When we take away the number of students with blue eyes and we take away the students with brown eyes, we're left with the fraction of students with green eyes. So all I need to do is do 1 minus 5/6 minus 1/10. So because I'm subtracting, the fractions need to have the same denominator. The lowest number divisible by 6 and 10 is 30. So if I times top and bottom here by 5, the denominator of this fraction becomes 30. If I times top and bottom of this fraction by 3, it will also have a denominator of 30. And that's what I need to be able to subtract, same denominator. So 5 over 6 becomes 25 over 30. and 1/10 becomes 3 over 30. I can also make this one have the same denominator. 1 whole is the same as 30 over 30, or 30 30ths. So now I just go 30 minus 25 minus 3, that gives me 2. So 2 30ths of people have green eyes, and we should simplify our answer to 1 over 15. So 1/15 of the class had green eyes. So let's look at this question here. In this class of 30 students, 3/5 of them play soccer. Of the soccer players, 1/9 of them play cricket. How many students play both cricket and soccer? So just be aware of what the question's asking. In the last one, it said what fraction, so the answer I gave was a fraction. Here it says how many, so my answer should be a whole number. So let's first calculate the number of students that play soccer. So this is 3/5 of 30. So you know from previous slide, of just means times, and if I'm multiplying by a whole number, I just write that whole number over 1. So to make this easier on myself, I'm going to cancel. 5 goes into itself once, and it goes into 36 times. So the number of students that play soccer is 18. Now I'm told 1/9 of them, of these soccer players, also play cricket. So the number of people that play both cricket and soccer is 1/9 of 18. So I'm going to do exactly what I just did. I'm going to change of to times, because of means times, and I'm going to write 18 as 18 over 1. 9 goes into itself once, it goes into 18 twice. So 1 times 2 is 2, 1 times 1 is 1. This just gives me 2. There are 2 students overall that play both cricket and soccer. All right, thank you so much for tuning into this video. This has been the luckiest maths teacher in the world. Have a great day.